Hi guys, this is lesson 1.2, the slope of a tangent. We have already mentioned this topic in advanced functions, but in calculus we're going to go into greater depth in which we have to solve the slope of a tangent by using limits. The tangent is a straight line that most resembles a graph near a point. So in order to find the slope of the tangent, you need 2 points on the tangent. Those 2 points will be P and P2. And the slope, which is usually represented by the letter m, will be equal to delta y over delta x. Delta y equals to y2 minus y1, and delta x equals to x2 minus x1, which is basically rise over run. The equation of the line L in this point slope form is y minus y1 equals to m times x minus x1. The equation of the same line in the slope y-intercept form is y equals to mx plus b, where m is the slope and b is the y-intercept of the line. The slope of a tangent is said to be the limit of the slope of the secant as q approaches p along the curve, and we will see an equation of this later on. The secant is a line through 2 points on the curve. Let's take a look at example 1 from the learning resources. Determine the slope of the tangent to the graph of the parabola f of x equals to x squared at p of 2 and 4. In order to find the slope of something, we need 2 points on that line. We already know one point is p. Let's imagine another point called q. Q will be equal to 2 plus h, and 2 plus h squared is squared because the original function is f of x equals to x squared. For h does not equal to 0, or else p and q will be the same point. The slope of the secant pq will be delta y over delta x, which is 2 plus h, all squared minus 4, divided by 2 plus h minus 2, which will be equal to 4 plus h. As h approaches 0, which means as q gets closer and closer to p, the value of 4 plus h approaches 4, and thus limit of h goes to 0 of 4 plus h is equal to 4. So the slope of tangent at p of 2, 4 to the parabola y equals x squared is 4. Now let's take a look at example 2 from the learning resources. Find the slope of the tangent to f of x equals to root of x at x equals to 4. First of all, we know that when x is equal to 4, f of x equals to 2. Let's now imagine our other point, like we did for q. And now let's imagine it to be 4 plus h. That's another point. When x is equal to 4 plus h, f of x is equal to root of 4 plus h. Now let's plug it into the limit equation, in which the slope equals to limit as h approaches 0 of f times 4 plus h minus f of 4 divided by h. Some of you might be confused by a moment because you say, wait a minute, when h approaches 0, the denominator will approach 0. So how can this equation be true? Well, we have to find a way that we can eliminate this h in the denominator. We know that f of 4 plus h is equal to 4 plus h under a root sign, and f of 4 will be equal to 2. We time it by its conjugate. And that will give us limit as h approaches 0 of 4 plus h minus 4 divided by h times in bracket root of 4 plus h plus 2. 4 minus 4 equals 0, and the two h's cancel out. So we will get 1 over root of 4 plus h plus 2. As h becomes 0, becomes closer and closer to 0, eventually it is 0, we get 1 over 4. Therefore, the slope of tangent to f of x equals to square root of x at x equal to 4 is 1 over 4. That's the end of this lecture. Thank you guys for watching, and I'll see you guys next time.